Welcome. I'm going to try to do 193, 194, and 195. Squish them together. Let's do it. 193 states, a study in a Midwest university is determining if there's bias. So to do that, they're trying to figure out if short people get paid less money. So they take the mean height for women and the mean height for men is different. So they want to separate the group of men and women, since men and women, a short man is not necessarily, the height of a short man would not necessarily be the height of a short woman. So if they're going to try to figure out whether there's bias in short people, it would make sense to separate men and women. So let's keep reading. It says, since the mean height for women would be different than men, the research examined men and women. Graduates were selected from 5 different majors. That makes sense because majors, depending on your major, you may have a different starting salary. For each major, a randomly selected woman that's at least 2 inches below the mean. So we're gonna call that a short person, somebody who is at least 2 inches below the mean height for women, was paired with a randomly selected woman who is at least 2 inches above the mean. So we made sure that we paired up 2 ladies, one that would be considered short and one that would be considered tall. Those 5 pairs were similarly selected for males from the same 5 majors, and we're going to compare. The starting salaries for each person in the pair was recorded, and really the stat we're calculating is the difference. So we did a whole chapter on calculating differences. So our H sub O is that there isn't a difference. So there's a couple ways to show that. I could say the average salary, or mu of a tall person, is equal to mu of a short person. There is no difference. But it looks like they've asked us to calculate salary of tall minus salary of short. So that would just be mu of tall minus mu short. We should assume there is no difference. So short people and tall people alike, equally likely to have a high or low paying job, having nothing to do with your height. So H sub A, I think we have a sneaky suspicion that the tall people may have something more than the short people. So taking a look at this, we're trying to quantify if we have that data based on, and they did the work for us, they took in the raw data and they spit out the statistics. So they took 10, they found a mean score of the difference. So it does look, in fact, that they didn't get 0 or anything close to 0. It looks like the tall people on average made $420 more than the short people. And it shows you the standard deviation plus or minus 4.73. And they gave us a confidence interval. So if we look at this, it's not looking good for the short people. It's looking here that they're 95% confident that the interval from $83 to $758 captures the true mean difference. And so they're definitely not thinking there is no difference. This looks like proof that there is a difference. So we're going to look through these. This is not a chi-squared test, since the confidence didn't turn 0. So that's usually our next step. We like this sentence. They're right. It did not contain 0. So if it contains 0, that'd be proof of H sub O, and we'd stop. But it did not contain 0. So we kind of like that one. And we actually kind of like this one. It says, since the confidence interval was above 0. And actually, D is a little bit better, because let's think about this for a minute. We're 95% confident that it is a completely positive number, meaning none of these are negative, which means that it is very likely the mean salary for tall people is greater than the mean salary of short people. So D is actually a slightly better answer than B. Because if 0 wasn't contained, this technically could have been negative $83 and negative $758. That's true, 0 is not in the interval, but this would be proof that shorter is greater. So technically D is our best answer. let's keep going. The next question was kind of a trick question. It says the following graph shows paid salaries for the 2002 Olympics during this time frame. So this graph here is not like a histogram. These are not frequencies like you're used to seeing. So in a skewness graph, you need frequencies here on this side. This is technically a time graph. So notice here, this is just the year that it happened. This is not the type of a problem where you would look for skewness and be able to have a curve and say, okay, that's the median, and since it's skewed, the mean sits to the left, so this is left skewed. So because of that, we're gonna say none of these above are true. Now I might be able to kind of play with these numbers, crunch them, and say, well, I think the mean, if this was the only years they worked, you could calculate a mean by calling up these dots. This is really these 8 years of dots. You could average these together if you wanted and maybe get 3, but none of these say only 3. So I'm gonna stick to none of the above. Now last one here, we're gonna look at this question. And this one I think is a trick question because my answer key says C, but when I crunch the number, I got a chi-squared value of 6.71, which would mean I would fail to reject the null, which is H sub O. So I'm gonna call this F. I like B, H sub O, at chi-squared, but it's failed to reject the null hypothesis. Now, how would I calculate that? You need a fancy calculator. So here are your raw numbers. I'm gonna show you how to do that really quickly. So you turn your calculator on, and you have to do a chi-squared two-way table test. So you gotta call it something. So this is talking about men, female, and happy and sad stuff. So I'm gonna type the word joy. I'm just gonna call my matrix joy. And then you have to hit control boxes and then the boxes again. So now I have joy colon equal, and I'm gonna go, this is giving me 3 by 3 is what I definitely wanna pick. So I pick 3 by 3. But here I have 2 rows. I'm gonna redo that. 2 rows, tab down, 3 columns. I wanna do 4 columns. Good to go. Oh, be careful. I just changed it again. 4 columns, tab again, hit enter. Now I'm gonna enter this raw data into my calculator. Okay, hit enter. So definitely my calculator has my information, and I am almost done. I hit stats. I want to do a stat test. I scroll down to chi-squared two-way test. My matrix, I called the word joy. So I'm going to select that, hit enter. I get a chi-squared value of 6.17, but my p-value, let me get that down. My p-value is 0.10, and that is actually more than my alpha. So because of that, I failed to reject the null hypothesis. I have some amount of evidence, but I do not have sufficient evidence to support H sub A. So I'm sticking to that. Thanks for joining us.